Hey, good morning, everybody in financial algebra world. This is Mr. Ainsworth, and we are going to get into your Chapter 3 review over the 7 sections. So get your review out. It's online in Canvas, so make sure you have that printed off. Get your pencil and red pens out. Get also your Desmos ready to rock and roll. So go ahead and give it a name. Call it up here, Chapter 3 Review Financial Algebra, so you can save your work as you go. You also have the option of using the scientific calculator here from Desmos, so you can use this as well, free to everybody. So this one here is great. I like the interface just a little bit better. However, you can't save your work, although you can print it at the end, which you're going to include in the review. So your choice to use this one, or if you use the graphing version, you can do the same calculations, use the keyboard at the bottom. Okay, so you can do that. And what's cool about this right here is that you can save your work as well as print it. Okay, so your choice. I'm just going to use this version here so I can save all my work. So let's get right into it here, and I'm probably going to break this up into a 2-part video just because it's kind of long. It's a chapter review, so I'll do the first half and then produce that part 1 for the first 8 problems, and then the part 2 would be the second half. All right, let's get right into it. Section, oh, by the way, this also corresponds to your workbook. So if you have your workbook, that would be really handy. Take it out and use it, all right, to your advantage. This comes from section 3.1. So from number 1 here, Monique purchases a $15,100 dining room set. She can't afford to pay cash, and so she's an installment plan, which requires a 24% down payment. The question is, what is the down payment? So let's work it out here. Okay, so the down payment is, we have to calculate 24% of the $15,100. So in general, you want to take your purchase price. This is how you do it for any of them. Okay, and you want to multiply it by your percentage down. Okay, percentage down. So what would that be? Well, in this case, we want Monique wants here a $15,100 dining room set, and you have to calculate 24% of that. Now 24% as a decimal is 0.24. Okay, so you can just go into Desmos here, type in 15,100, double check your numbers as you go, times 0.24, and it's about $3,624, okay, for the down payment. So she doesn't kind of have to come up with the entire amount to take it home. She has to come up with $3,624 as a down payment, and then she takes it home, and then she just pays it off using an installment plan. Number 2, and again, all these questions come out from section 3.1, so use your notebook to your advantage because we went through all these problems. Right now we're just reviewing, okay? So keep that in mind. We're just getting good at what we learned in the past. Number 2, Snow House sells a $3,300 snow thrower on a installment plan. The installment agreement includes an 18% down and a 12-month payments at $325 each. So what's the total amount? What's the total amount of monthly payments? Okay, so here we go. So total amount, AMT is amount. What you want to do is you want to take the number of months, which is 12 in this case, the number of months, and you multiply it by your monthly payment. That's how you get the total. Okay, so we have a 12-month plan, so it's going to be 12 months here. And we're going to be charged, or we have to pay $325 per month. Okay, and the question is, what is that? So let's go ahead and multiply 12 times 325, and we have a total amount of payments of $3,900. So you can see that we have to pay more than the $3,300. Okay, things aren't free. So when you do this sort of thing called an installment plan, there's a finance charge. In this case, there's a $600 finance charge because we pay a total of $3,900 total. All right, number 3. In this case right here, Lisa purchases a professional racing bicycle that sells for $5,000 including tax. It requires a $300 down payment. The remainder plus the finance charge is paid back monthly over the next 1.5 years. Okay, so 1.5 years, that's 12 months plus 6 more. So this is 18 months, just so you know. So keep that in mind. 1.5 years is 18 months. And the monthly payment right here is $270-$275. The question is, what's the finance charge? To calculate the finance charge, we need to figure out the total paid, which is what we just did above. All right, so let's go ahead and let's figure out starting from the beginning, what's going on here? So we have we have a bike that's selling for $5,000, and we're going to put $300 down. So step one, we got to take $5,000, okay, and well, let's just put $5,000 here. All right, minus $300 down payment. Okay, so we have a loan amount of $4,700. So you take 5,000 minus 300. All right, and that's 4,700. So, and the question is, what is the finance charge? We need to figure out what's the total paid. So step two. All right, we got to figure out the total paid, just like we did above. Total amount paid. Total amount paid. So we do know that we're going to be paying $272.75 for 18 months. So just like in number 2 right here, we've got 18 months total times the monthly payment of $272.75. So what we want to do is calculate that. So 18 times 3, excuse me, not 3, 272.75. Okay. And notice that we're paying $4,909.50 overall. Okay, so $4,909.50 overall. That's what the total paid was. Now, step 3, the finance charge. So the finance charge, or the interest, okay, that's synonymous with the interest right there that you're going to be paying. The cost of the loan, okay, would be the difference between this and what we owe. We owe $4,700 in step 1 because we had that $300 down payment. So what we want to do is subtract. Okay, you're going to take your $4,909, which is the total amount of month you pay, and you want to subtract the $4,700, and that would be $209.50. Now, if you don't know how to calculate that in your head, you just type it in, $49.09.50, subtract the $4,700 because you still owe that, okay? And there's your finance charge of $209.50, okay? So $209.50. It's the total amount paid minus the amount remaining. In this case, the $4,700. Okay. So there you go. That's number 3. Let's do a few more. All right. Now going into section 2 now. Section 2. Open your notebook up, your workbook up to section 2, and let's review how to use this table here, which covers the monthly payments per $1,000 principal. That's the important part. Okay. These are the monthly payments per $1,000 of principal. Okay. Not for total. Okay. But per 1,000. So in this case, in number 4 here, Mia borrows $56,000 for 4 years and an APR of 7.5%. Okay, what's happening here? So first of all, she wants to borrow $56,000, not $1,000. So the first thing I do is I calculate the multiplication factor. I take $56,000 and divide it by 1,000. So whatever the monthly payment is on this schedule here, this table, all right, I've got to multiply it by 56. 56,000 divided by 1,000 is 56. Okay, that's step 1. Step 2, you want to calculate the monthly payment. Okay, now the way you do that is you figure out what it is for the first 1,000. Okay, so let's go to the table here, and at 4 years at 7.5%. So you go find 7.5%, you find 4 years, and you go down and across. And so it's going to be $24.18 for the first $1,000. But Mia wants to borrow $56,000, so you got to multiply this number here in the table, the $24.18, times 56. Okay, so to calculate this, we got 56 times this payment, this monthly number here, $24.18. Again, this is for the first 1,000, but I have to multiply it by 56 to get a payment for the $56,000 principal. Got to keep that in mind. All right, so let's enter in 56 times 24.18. All right, and really, this is going to be a good sized number here, because $56,000, let's say it's a car or something. All right, that's a hefty monthly payment. All right, and it's going to be about $1,354.08. All right, it's quite big because $56,000 is quite a bit of a principal to be borrowing. Now number 5 is similar here, but it's a smaller loan amount. So let's say you on number 5 you want a $4,100 loan, 2 years, which is 24 months, and then at an APR of 7.75. Okay, so you find 7.75, which is right up here in the table. 2-year loan now. So 2 years is here, so you go down and across. And so to borrow $1,000 at 2 years at 7.75%, we're gonna have to pay $45.11. Okay, $45.11 for the first $1,000 borrowed. But in this case, we want $4,100. So we got to take that and divide it by 1,000, and that is 4.1. So this number here of $45.11, I have to multiply it by 4.1 to get the monthly payment. So my step 2 here is I got to calculate the monthly here payment. I got to take 4.1, multiply it by this number 45.11 to calculate my monthly payment. So you go down to Desmos here, 4.1 times 45.11. So my monthly payment right here is going to be about $184.95. Okay, so $184.95. That's monthly. Okay, now we want the total amount paid. So this is a 2-year loan. This is 24 months. So my next step here, step 3 here, to get the total paid, I've got to take this number here, $184.95, and I got to multiply it by 24 because this is a 2-year loan. So I got to multiply by 24 months. So 24 times the 184.95. Let's see what that gives me. So again, this is a 2-year loan, and obviously 2 times 12 is 24. So I got to take 24 times the 184.95, and that's going to give me about $44.38. Okay, so $4,438 and roughly 80 cents total. So step 1, you figure out your multiplication factor. Step 2, you figure out your monthly payment. And step 3, you figure out your total paid by multiplying by the number of months. And for a 2-year loan, that's 24 months. Okay, so it's a 3-step process right there. Now number 6, finance charge. So we're going to use the step process above. We're going to figure out the monthly payment and the total paid, and then after that we can figure out the finance charge. Now this one here, we want a $6,000 loan. So 6,000. Again, this is step 1 divided by 1,000. It gives me 6. There's your step 1. To get the monthly payment, okay, we got to take whatever it is per 1,000 and multiply it by 6. So let's look at a 2-year loan at 8.25%. So here we go. 8.25% is here. 2-year loan is up top. So you go down and across, and I see 45.34. So I have to multiply that by 6 because I want to borrow $6,000. So 6 times this number here of 45.34. So what would that be? So let's figure it out. So 6 times 45.34 gives me about $272.04. So $272.04. That's monthly. Now I got to figure out the total paid. That's my next step. So the total paid, again, I'm just doing what I just did in number 5. So the total paid over 2-year loans, this is 24 months, is equal to 24 times my monthly payment of $272.04. So you type that in. Okay, it's 24 times 272 and 4 cents. Okay, and we get about $6,528.96. So $6,528.96. Okay, that's step 3. Now to get the finance charge. Oops, I'm sorry. Hang on. Let me just readjust something here. a little computer glitch. To get the finance charge, what I need to do is take the total paid and subtract the original loan amount, the principal. So the last step, the finance charge, which is the interest basically, is $6,528.96 minus the original loan amount, the principal here, $6,000, which is obviously $528.96. Here's your finance charge. So this one here, number 6, is a culmination of numbers 4 and 5 put together. Step 1, this is step 1, right? Step 1, we divide the loan amount by, in this case, by 1,000, because this table shows that it's the monthly payment per 1,000. So 6,000 divided by 1,000 is 6. Step 2, we calculate the monthly payment. Step 3, we calculate the total paid. In step 4, we calculate the finance charge. So this puts it all together right here. All right, moving on. In section 2, you learn how to calculate the monthly payment without using the table, using what's called the monthly payment formula. All right, and this is big. This is going to be used quite a bit. So instead of using the table, we can calculate the monthly payment using this formula here, where P is principal here, T is the time in years, and then R is your interest rate. Okay, so let's get started here. So Rebecca wants to take out a $12,800 loan. There's your principal right here. T is 4.5 years. T is 4.5. All right, APR is 0.0 or 7.16% is 0.0716. And so you write down what you know. So we know the time, the principal, the APR, and we want to figure out the monthly payment. Okay, so here we go. So let's set it up first. Always show setup here. And then what we want to do is that Rebecca here wants to take out a $12,800 loan times R divided by 12, so it's 0.0716 divided by 12 times your basically your compound interest formula, 1 plus 0.0716 divided by 12 raised to the 12t power. Now 12t, so there's in 4.5 years, I'm going to go back up here, this is years, that is, how many months is that? So that's where the 12 comes from. So 12 or 4.5, all right, times 12, that should be 48 plus 6 or 54. But if you don't know that, you just type in 4.5. 4.5 times 12 will give you the number of months in in 4.5 years. So this is 54 months total. That's going to be your exponent. Okay, so in 4.5 years, that tells you that there's 54 months. So I'm going to raise it to the 54th power here. And then you divide that by 1 plus 0.0716 divided by 12 to the same exponent, all right, 54, and then don't forget the minus 1. Okay, and what would that be? So the monthly payment for this, let's enter it in. So 12,800. All right, just use parentheses here. Desmos knows how to deal with that. So 0.0716 divided by 12. Double check your values here. Close it off and then times it by your compound interest formula, 1 plus 0.0716 divided by 12. Close that off and raise it to the 54th power because we have 54 months and 4.5 years. Get out of the exponent before you divide. Make it look identical to what you have on paper here. So divided by 1 plus 0.0716 divided by 12. And raise that to the 54th power, same exponent. Double check your numbers as you do this. Get out of the exponent before you subtract the 1. And you should have a realistic number here, a month, okay? So 277.97 sounds realistic. So 277.97, okay? That's a 7. $277.97. It's a monthly payment. This is per month. Okay. And that is what we started with in the beginning of the chapter, this crazy monthly payment formula. I even generated it with you guys. I showed you how to derive that by using logarithms, okay? But I'm not going to test you on that part, just application part. All right, section 3. Open your notebook to section 3 and let's just review what it means to have an unsubsidized federal loan versus, in number 9, a subsidized loan, okay? totally different situations going in here. They're both federal loans, simple interest loans, but unsubsidized means that you have to pay that interest back, basically. Okay, but let's read it first. Chris got a $31,000 unsubsidized student loan at 5.29% for 10 years. He knows that he has the option of beginning repayment after 4.5 years. They assume that you're going to college for 4 years, plus they give you 6 months. That's on a 4.5 year period. And at that time, you're going to have to start paying your payments back. Now, unsubsidized means that the government does not pay your interest. So basically, you must, okay, this is what unsubsidized means. You must pay the interest back. Okay, that has been accrued. So you must pay the interest back that was accrued, all right, during the 4.5 year period. During the 4.5 year period. So the question is, how much is that? Okay, so remember, all federal loans are simple interest. Okay, so federal loans, okay, are simple interest. That's important. So because of that, you're going to be using I is equal to P times RT, principal rate times time, because they are simple interest loans. All right, and let's calculate that. Let's calculate the interest that was accrued during the first 4.5 year period. So principal in this case is $31,000. The rate R is 0.0529, and T in this case is 4.5 years. So you take 31,000, multiply it by your interest rate 0.0529, times it by 4.5 years, right? And that gives you obviously some number, right? So let's calculate that. Enter in 31,000. Multiply it by 0.0529, multiply that by 4.5 years, because you're in college 4 years, but you got a 6-month grace period, at which time you do not have to pay it back unless you want to. So look at that, we have to pay back an additional $7,379.55. So $7,379.59. This is what we have to pay back. So the new principal that we have to pay back is the original principal, $31,000 plus the interest, principal plus interest, which is $7,379.55. Okay, so let's do that. So take 31,000 and add it to the interest that were accrued, so $7,379.55, and you're going to have to pay back $38,379.55. Okay. So that's a good chunk of change right there. So $38,379.55. That is your new principal that you will have to pay back after 4.5 years being in school, plus the 6-month grace period. Now this is the number that your monthly payment is based upon. Okay, so we're going to start off by financing, or you're figuring out your monthly payment based upon not the original principal, but this number here. So $38,379.55. Okay, this is an unsubsidized loan, which means you have to pay the principal plus interest. Principal plus interest. Okay, that's the difference between subsidized and unsubsidized. And now we have to multiply this by our interest rate, 0.0529 divided by 12 times 1 plus 0.0529 divided by 12. Now here you got to raise it to the 12t power. Now this is a 10-year loan. Look at this. Now we're paying it off for 10 years. And 10 times 12, okay, is obviously 120 months. Okay, so I have to raise this to the 120th power. Divided by 1 plus 0.0529 divided by 12 to the 120th power. Okay, let's highlight those exponents. Okay, they both have 120th power there. And then don't forget to subtract 1 from the denominator. Okay, look at your monthly payment formula. And this should be, in the hundreds of dollars, okay, for this amount. So let's figure this out. So here we go. So $38,379.55. You start with the principal plus interest right here, times the monthly interest rate, 0.0529 divided by 12. That's your monthly interest rate. Whenever you take the APR and divide it by 12, you get the monthly interest rate, okay? Times the compound interest formula, 1 plus 0.0529 divided by 12. All right, and then you got to raise it to the 120th power, because you're going to pay this off over 10 years, and that's 120 months. So this exponent of 120 is always going to be used in these federal loans. And get out of the exponent, divide it by this number here, so 1 plus 0.0529 divided by 12. Okay, raise that to the 120th power 2. Oops, I didn't do that right. Raise it to the 120th power. Gotta be careful right there. Get out of the exponent before you subtract 1. And you should have a reasonable number here. This is about $412.54. $412.54, round up. Okay? Now we're going to use that to calculate the total paid, because we got to pay that for 120 months. So we're going to take 120 months, multiply it by this number here, our monthly payment, which is $412.54 months. So let's calculate that. So 120 months times our monthly payment, $412.54. And we're going to have to pay back $49,504.80. That's a lot. So $49,504.80. Okay. Now I got to figure out the interest or the finance charge. So the interest or the finance charge is found by taking the total paid, all right, minus the original principal. So we got to take this number here and substitute it in. All right, so we just calculated that we pay overall $49,504.80. The original principal was $31,000. That's what we borrowed. So the difference of these two would give us the finance charge, or the amount paid, or what's basically called the cost of the loan. So if we take $49,504.80 and subtract $31,000, all right, we get a pretty hefty number here, over roughly $18,500. That's a lot of money paid over time. That's the cost of the loan, guys. Believe it or not. So it's not cheap, okay? Taking out a big loan, you're going to have to pay a lot back. Okay, you're going to have to pay over half back. Okay, or half on top of that of the original principal. Yep, that is a lot. Now the next problem, number 9, is related. And there's a big difference between subsidized loans and unsubsidized loans. So unsubsidized loan means that you have to pay the principal plus the interest back. The subsidized loan means that you don't have to pay the interest back. The government pays it for you. And that's the key difference between subsidized versus unsubsidized. Okay, so the principal in this case on Kayla's problem here is $29,000. She wants to borrow that much. But this is a subsidized student loan, a federal loan for 10 years at 2.29%. She has the option of beginning payment in 4.5 years. So the question is subsidized. Now, subsidized means that the government pays the interest for you. So the government here, the Department of Education, all right, pays the interest, okay, that is accrued, all right, during the 4.5 years, which is kind of nice. The question is, how much is the government taking care of? Okay, so she only has to pay the $29,000 back, not the $29,000 plus the interest. But just for curiosity's sake, how much is she really saving? How much is the government taking care of? So let's calculate it. Let's see that number here. So again, this is I equals PRT. This is a simple interest loan. All federal loans are simple interest. And so you got to take $29,000 times your interest rate, and this R up here is 0.0229. So 0.0229 times 4.5. This is the amount of money the government's taking care of. So let's figure this out. Let's take 29,000 times 0.0229 times 4.5. All right. And look at this. I mean, the government's taking care of $2,988.45. She doesn't have to pay that back, which is kind of nice. That's what subsidized means. So the government subsidizes you. They take care of it for you. They pay off the $29.88 and 45 cents, and you save that money basically. So how much money does she have to pay back after the 4.5 period? Just the principal. Not the principal plus interest, just the principal of the loan. That's why subsidized loans are nice. All right, so she has to pay back only $29,000. The government pays this for her. And that's nice. That's what subsidized means. The government pays the interest for you, so she only has to pay back the $29,000 after 4.5 years. Okay, and then when she has to pay back the loan. So let's calculate the monthly payment for her. So you have to use this number here. You start off with $29,000. That's what she's financing over 10 years. Now her interest rate is a nice interest rate, 0.0229 divided by 12 times 1 plus 0.0229 divided by 12 to the 120th power here. Again, this is a 10-year loan, so this is 120 months, as I said on the previous one. Divided by 1 plus 0.0229 divided by 12 to the 120th power minus 1. And again, this has to be a realistic number here. So when you enter this in Desmos, you can copy the previous formula and put it down here, or you can just type it in again. I'm just going to type it in just for funsies. And then times 0.0229 divided by 12. That's the monthly interest rate. Times the compound interest formula, 1 plus 0.0229 divided by 12. And then raise it to the 120th power because this is a 10-year loan, which obviously is over 120 months. And then I got to divide that by 1 plus 0.0229 divided by 12. And raise that to 120th power again. Then get out of the exponent before you subtract 1. And notice that's a reasonable number. Okay, her monthly payment on this one is just $270 and looks like 62 cents. Okay, so what is her total that she pays back? Well, you got to take 120 months times the monthly payment of $270.62. What will that give her? So let's see here. So 120 months times 270.62. So right here we have a total amount paid of $32,474.40. That's the total paid. So you can figure out the interest now, or the finance charge. Okay, by taking that number, which is $32,474.40, subtract the original principal of $29,000, and this will give you the interest or the cost of the loan. So let's try that. So $32,474.40 minus the original principal of $29,000. Okay, and the cost of the loan or the finance charge or the interest is $3,474.04. Okay. Okay, so well, there's a big difference between number 8 and number 9. Number 8, unsubsidized means that you have to pay the interest back plus the principal, okay, which is calculated into the monthly payment. Subsidized means that you do not have to pay the interest back, so you're only calculating the monthly payment based upon the original principal only. There is a big difference between the two. And I'm going to pause here. In my part 2 of the video, I'll start talking about the private loan in my part 2 of the video. All right, I'll see you then. This is Mr. Aynes. Bye-bye. Hey, good morning, everyone. This is Mr. Ainsworth, and we are in financial algebra here, doing the second half of our chapter 3 review. Now, in part 1 of the video, I did questions 1 through, I think, 8. Let's go through that here. No, 1 through 9, actually. We covered 1 through 9. So I'm going to need to start part 2 on number 10. Okay, but let me review something that we talked about in the last part of the first video here. Okay, so there's a big difference between an unsubsidized federal loan and a subsidized federal loan. Okay, so an unsubsidized federal loan, the interest has to be paid back after the 4.5-year period. 4 years in college plus 6 months grace period. So after 4.5 years, you got to pay that back, okay, over 10 years, because these are 10-year federal loans. So if it's unsubsidized, the interest and the principal has to be paid back. If it is, okay, excuse me, a little tech issue there. If it is subsidized, well, something's different happening. If it's subsidized, that means that you don't have to pay the interest back. Okay, the government's going to take care of that for you, and we did that in number 9. So let me transition to number 9 here. So number 9, we talked about how a subsidized loan works, and that the government pays the interest that is accrued during the first 4.5 years, which could be a lot depending on what you borrow. So in this case, $2,988.45 was accrued in interest. All right, but the government pays that for you. So to calculate your monthly payment in Part D here, the monthly payment depends only on the principal, not principal and interest. Okay, so big difference there. Now in number 10, in respect to a private loan, there's no deferment of 4.5 years. Okay, when you take out a private loan, not only is the the interest rate a lot higher, all right, but you got to start paying immediately on that private loan. No 4.5-year deferment period. So let's go through it here. We calculate the monthly payment in a similar way here. So let's go ahead and set this up. Okay, so in this one here, Marley decided to get a $22,500 private loan. Okay, so that's her principal, $22,500. All right. She has been offered a private loan for 10 years. Okay, so the time is 10 years or 120 months at an APR of 5.8%. So we know from here that the interest rate is 0.058. We know that the time is 10 years, so T is equal to 10 years. We're talking about 120 months. So that's 120 months total. And that number is in the exponent. So when I look at the length of the loan, that tells me what the exponent is in the monthly payment formula. So we take 22,500, multiply it by R divided by N, which in this case is 0.058 divided by 12, times your compound interest formula, 1 plus R divided by N, so 0.058 divided by 12, to the 120th power. This is 12 times 10. So that's 120 months. So raise it to the 120th power, divided by 1 plus 0.058 divided by 12 to the 120th power, same exponent, okay, minus 1, okay? Not minus 1 from the exponent. This is just whatever, all that expression is, minus 1. So this is your monthly payment on this private loan. So it should be some reasonable number here, like in the hundreds, okay? So let's enter this in. These on my Desmos here, go ahead and open up the Chapter 3 review and record all your calculations here and save it in the Chapter 3 printout, so you can print off all your work and submit it in Canvas. But let's type this in. So 22,500, all right, times 0.058 divided by 12. Oops, okay, already I see right there. My keyboard, I didn't get that division button, divided by 12. So always check your work here, because it's easy to miss a keystroke. All right, times 1 plus 0.058 divided by 12. Now you got to raise that to the 120th power, because we're doing this. This loan is for 10 years or 120 months. So we raise it to the 120th power. Get out of the exponent before you hit division. All right, divided by the compound interest formula, 1 plus 0.058 divided by 12. Okay, let's take that to the 120th power, same exponent. Get out of the exponent before you subtract 1. Okay, and notice that is a reasonable number right there, $247.54. So the monthly payment, $247.50. 54. Now that's a reasonable payment. So now we want to figure out the total interest. Okay, so once this is step one. Okay, so step one, calculate the monthly payment. Okay, step two, you got to figure out the total paid. All right, so to do that, we got to take our monthly payment, multiply it by 120 months, excuse me. All right, so the total paid is equal to 120 months, because this is a 10-year loan now. You got to think about what you're doing, times your monthly payment, which is 247.50, 54, excuse me. I don't know why I keep doing that. So you take this and bring it over, and you get a total payment of something. So we enter this in 120 times the monthly payment of 247.54. Got it right that time. All right, and your total payments are about $29,704.80. So $29,704 and looks like 80 cents. That's what you paid in total. Now to get the interest, all right, you got to go to step 3, all right, and you got to take what you paid and subtract the principal. Aha. So step 3. Okay, what you need to do is you got to calculate your interest, or the finance charge. Finance charge, interest, same thing. Cost of the loan, you can think of that as well. You take the total paid minus the original principal, P. And again, the original principal is right up top. It's the $22,500 loan. Okay, so let's calculate that. So the next and last step is we take 29,000 we paid. It's right here, $29,704.80. We subtract the original loan amount of 22,500. And what do we get? Okay, so $29,704.80. All right, subtract the original principal of 22,500, and we get an interest, or a finance charge, of $7,204.80. So this is the interest, $7,204.80. So we have a 3-step process here, as we usually do. First step, you calculate the monthly payment. Step 2, you calculate the total paid by multiplying the monthly payment by 120 months, because this is a 10-year loan, or 120 months. And then step 3, we take the total paid and subtract the original principal, which in this case is $22,500, and we get an overall interest payment, or overall interest amount, of $7,204.80. There we go. All right. Now, next one here. This is again, this is section 3.4, and this is finding the term of a loan, the number of years over the life of the loan. Okay, so let's figure this. Let's read it out first. Okay, so Marissa here in this problem wants to borrow $12,000. This is the principal right there, to purchase a boat. Okay, great. After looking at her monthly budget, she realizes that all she can afford to pay per month is the $325. So there's your monthly maximum right there. Okay, so M, actually let me write this out. So principal P is $12,000. M, your monthly payment max is $325. Okay, these are dollar amounts. The bank is offering a 6.5% loan, so R is 0.065. So already, see, I read the problem and I write down what I know. Okay, and then you read the question. So what, right here, what should the length of the loan be? That's T. All right, T, how many years? How many years? What should the length of the loan be so that she can stay within her budget? So remember, the longer the loan, the lower the monthly budget. The shorter the loan, the higher the monthly payment will be. Okay, so just keep that in mind. So let's calculate this. It doesn't matter which formula you use, all right, but you just got to set it up. So the log, okay, of M divided by P. So 325 divided by P, the principal of 12,000, just 12,000. So you're going to take the log of that minus the log of this difference right here. So we're going to take m divided by p, which we just already wrote down. So 325 divided by 12,000 minus r divided by 12, 0.65, excuse me, 0.065 divided by 12. Let me write that a little bit more clearly. So 0.065 divided by 12. There you go. Make sure you put the parentheses around the two fractions. Okay, we're going to take the log of the difference. All of that's going to be divided by 12 times the log 1 plus r divided by 12, so 0.065 divided by 12. Okay, and let's calculate this. So here we go. So I need to put parentheses on Desmos. I need to put parentheses around the numerator. So I'm going to highlight that. So I'm going to double up on the left side. So put this entire numerator in parentheses. So we'll start off with the log. You go functions on Desmos, go to miscellaneous, type in log. We're going to use a common log. All right, 325 divided by 12,000. Okay. Now close off the parentheses right there, minus the other log. So minus function, select another log. Oops, what happened here? Where's my work? Oh, here we go. I don't know what happened there. So the log of 325 divided by 12,000. Double check right there. Get out of the denominator. Subtract the other fraction. So 0.065 divided by 12. Oops. Okay, so see that right there? Okay, so let me type that in correctly. So minus 0.065. I was just going too fast on the computer. So divided by 12. Okay, now you go on the outside of the parentheses. Now you press the division button, and now, see, this looks correct right here. So divided by 12 times the log. So function, go miscellaneous log. I do not know why it keeps doing that. Apologize. So divided by 1 plus 0.065 divided by 12. That should be it. So now we have about 3.44 years. Okay, so watch this. So 3.44 years. Now, they don't have loans for 3.44 years, guys. You either take out a loan for 3 years or 4 years, but not 3.44 years. And if she wants to stay in budget, if her max amount right here, all she can afford is $325 a month, you want the longer loan. So you want to round up here, okay? Round up to make the payment less than $325. So the longer the loan, the smaller the monthly payment's going to be. So we round up. So now T is going to be about 4 years. You want to pick a 4-year loan and a 3-year loan. Okay? Always round up. Let's highlight that. Key concept right there. Okay, round up. Okay, so you got to go from 3.44 to 4 years, because again, they don't offer loans for 3.44 years. So you don't have that in a banking system. Okay. All right, moving on. Number 12. We'll do some regression analysis. So the table shows in this right here, a $50,000 loan. Notice that at time equals 0 is $50,000. Has an APR of 5.5%. That's how I generated these numbers here on Excel spreadsheet for over 15 years, from 0 to 15 years. All right, calculate or use regression to determine the curve of best fit for the data. We're going to do linear regression. Okay, so now linear regression, y is equal to, tilde, okay, tilde, mx plus b, so that's a linear. Quadratic, okay, so that's going to be approximately equal to, so we're going to use the tilde symbol. Now that's the quadratic is second degree, so this is first degree, this is second degree, so it's going to be y tilde, ax squared plus bx plus c. Notice the highest exponent is 2, that's second degree, and then cubic, that's going to be y tilde equals, or approximately is equal to ax cubed, this is third degree now, plus bx squared plus cx plus d. So third degree, second degree, first degree, 0 degree. That d is a constant. And I'll talk about that here in Desmos here in a minute. And then after that, we're going to predict the balance at 9¼ years, which at t equals 9.25, it's somewhere in here somewhere between 9 and 10. What would the balance be? Question mark. What would that balance be? It's obviously between 25,000 and 21,000, but I don't know exactly what it is. All right. So let's go through all of this. Now, what you guys need to do is enter the data in. Now, I already have the data in. All right. Now, if you don't have the data in, this is what you do. You have to go up here to the plus sign. You have to add in a table. And then you have to put your x values in here first from 0 to 15. Now, the easiest way to do that, and I'm just going to talk about this, and then I'm going to start calculating here, is to go 0, enter, 1, enter, 2, enter, 3, enter, and then just hit the enter button. Watch this. And just keep going, hit enter button until you get to 15, okay? All right. And then once you do that, then you go up here to the y values and you start typing in all these numbers. And you double check your work because it's easy to get your numbers incorrect, okay? So do that here first. So pause the video, do that, and then press play when you're ready. Okay, I'm going to assume that you've already entered your data in. So we want to enter in the regression line. So let me show you how to do that. Okay. So what we're going to do is we're going to go down to the next row. Okay, we got the data above it, and we're going to go down to the next row here in Desmos, and we're going to enter in our linear regression line. This is a first degree linear regression line. So we're going to go y. By the way, up here at the top of the table is x1 and y1. So when you enter in your variables, you enter in y1. When you see an x, you put in x1 because that is obviously the title of the table, okay? So we're going to go y1, just type it in. Tilde, go shift, you have to use your shift button here, and the tilde is in the upper left-hand corner of your keyboard. So go shift tilde, okay, and notice that it looks just like what I have there on the screen on the left. And you go mx1, so mx1, make sure you type in x1 because otherwise this won't be correct. Your x values are under x1, not just x. Okay, and then you go plus b, so just type it in. And this is your linear regression line. Now let's just open this up here a little bit. Now you're not going to be able to see the data until you scale the graph. So we're going to hit the wrench icon and we're going to change the values on the x-axis from 0 to 15. That sounds about appropriate. Step 1. Just do what I'm doing right here. We've done this in class together. And the y values start at 50,000 and they go to 0. So the y values 0 to 15,000 or it's 50,000. So you type in 50,000 and put a step of, let's say, I don't know, 1,000 maybe. Okay. And you'll be able to see the grid. Okay, you can zoom out or in. And you notice that the linear regression line does not go through all the data points. So we should be able to figure out a quadratic regression curve that would better suit better fit the data, because this is a curved set of data, not linear. Okay, so if they're decreasing, thank God the line's decreasing, so that's good, but it's not the best line of best fit. Okay, the best line of best fit. Okay, let me get my curve back here. There we go. All right, so let's enter in the next one here. So the quadratic one, let me decrease this so you can see it here. So look on the left side of the screen. Y is approximately equal to tilde ax squared plus bx plus c. We got to enter that in. So type in y1 tilde. So go shift tilde ax1. So ax1 squared. So the square button, you go shift 6, and that'll give you your exponent. And you type in 2. Then use the right arrow key to get out of the exponent. And then you go plus bx1, all right, plus c. There's your quadratic regression line right there. Now if I go back to the graph here, you're going to see that this is a better line of best fit. You can see how the curve in blue, which is your quadratic regression curve, or regression line, it goes through the data points. But is quadratic or cubic better? You know, what goes through the data points best? So we'll have to compare that with the cubic and see. And we'll look at the r squared values and compare them. So right now we got r squared for the linear is 0.98, r squared for the quadratic is 0.999. So I can already see that quadratic regression is much better. Okay, so let's go enter in the cubic. So let's go y1. Again, y1. Tilde, so go shift tilde. Okay, on this one you got to go ax1 to the third power. So ax1 and then go shift 6, which gives you your exponent, but type in 3 for a cubic. Go right arrow key, get out of the exponent. Add it to bx squared, so bx1 squared, so go shift 6 and then enter in 2 for the square. Get out of the exponent again, plus cx1 and then plus d for the constant. And this is your cubic. Now when you do this, if you look closely here, if you get really close and zoom in, remember green is cubic and blue is quadratic. You notice that the green, the cubic, runs through the data points better. It approximates the data points better than quadratic regression. And by looking at the values right here too as well, oops, sorry. R squared is 0.998, the previous one is 0.9998, so they're very, very close. Okay, they're almost equivalent in terms of validity, okay, in terms of accuracy on predicting. So let's write down what we have so far. Okay, so we have, let's write out the equations here because you guys are going to need to do this. Let's do it, let me screenshot this here. Okay, let me just put this side by side. There we go. Okay, so looking at this, we can write our equations out. So my linear function, so this one's linear. So looking at this right here, y is approximately equal to m, the slope is negative 3,317, so negative 3,317.2 times x. Remember, it's m times x plus b, plus this b value, which is 52,979. There's my linear regression. What's called the line of best fit, you guys, okay? Now the second one's called my quadratic regression. It's second degree. Okay, so you just follow the formula. So y is approximately equal to ax squared. So negative 89, roughly negative 90. If you round that to the nearest tenth, you're going to have to round that to negative 90. So we'll round everything to the nearest tenth. So negative 90 x squared. Okay, your b is negative, so minus 1967.9 x. And then c is positive, so plus 49,830.6. There's the quadratic curve. And now my cubic, this is called a cubic regression, which is sometimes better than the quadratic, sometimes not. It depends on the data, okay? So because again, you compare these, the r squared, they're the same. Well, it seems to be the same. It's only written down to the first 4 digits, but they're probably different after the 4th digit. So, but don't really know because Desmos didn't give me that kind of accuracy. So here, y is equal to, or approximately equal to, a, which is negative 0.7. This is just rounded to the nearest tenth, x cubed. B is negative 73.7, so minus 73.7 x squared. And then C is negative, so negative 2062.2 x. And then D is this big number here, plus 49,930.6. 929 point, let's say 1. So yeah, there's a there's a lot going on here. There's your cubic, okay? So those are your regression lines, and what we're going to do is we're going to use this one right here. We're going to use the cubic to predict. Okay, so how do we do that in Desmos? Because in part D, look at part D here, it says use the cubic regression to predict the data when x is equal to 9.25 years. Okay, so let's do that in Desmos. So we're going to go back here, go down the next row. We're going to type in the cubic regression line. Okay, so here we go. We got to type this guy in. So let's do it. So y equals, use the equal sign this time. So y equals negative 0.7. So negative 0.7 x cubed. Just type it in. And then minus 73.7 x squared. Notice that I'm using the equal sign and I'm not using the subscript 1. Okay, we only do that for regression. But when you use a prediction, or when you write an equation to predict a value, you want to use just the equal sign, okay? And then minus the 2062.2 x, and then you got to add the constant of 49,929.1. And then when you do that, you got this equation here. What you want to do is convert it to a table so you can evaluate it at 9.25. Because in the table, we want to figure out the balance, okay, when t or x is 9.25. So to do that, you come up here to the wheel, cog wheel, okay, the gear, the cog, and then you select table. So go down to your equation, you convert it to table, and the default is -2, but obviously you don't want to type in -2, you want 9.25. You know, so x is, what is x, or the balance when x is 9.25? So you type in 9.25, and it tells you what the balance is right here. And the balance is $23,993 and roughly 78 cents. Okay, and there's your balance when at the year 9.25 years. Okay, so that is your prediction right here. There's your prediction right there. All right. Okay, so this right here, let's review what we've done. So at 9.25 years, okay, you have, this is a balance. And notice that it's between these two numbers, okay, which should make sense because the balance is decreasing over time all the way down to 0 on the 15th year because you're going to pay this off in 15 years. And the number has to be between 25 and 21. Not the average, not directly in the middle, because this is not linear, okay, I can tell you that. So don't use an averaging method on a non-linear set of data. All right, and that is how you do it in Desmos. Hit save on Desmos, save all your work, because you can print it out and submit it with all your section work. Okay, and that's how you do the regression and a prediction. All right, and again, I screenshot. You can screenshot too when you submit it to Desmos if you like, or you can just print it off using the print button up here at the top, and then submit all your work. But we're not done yet. Okay, so let's get started. Section 3.5. So again, look in your workbook. I was talking about this in class today. Use your workbook and use it as a resource. Use your workbook. People forget about that. That's just, we've done all these problems, you guys, in the sections. So might as well use your workbook to review, okay? On this one here, APR is 24.2%. What's the monthly interest rate? The MPR, monthly periodic rate, okay? And it's, well, the monthly interest rate, monthly periodic rate, either one, same thing. So what you want to do, the monthly periodic rate is found by taking your annual rate, your APR, All right, and simply divide it by 12 because there's 12 months per year. So this is 24.2%. Divide that by 12. So let's go down here to the next line in Desmos and just type it in, 24.2 divided by 12. Boom. All right, and we have about 2.016 repeating. So 2.016 repeating percent. Okay, that's actually repeating decimal right there. All right, now the average daily balance for Dave's last credit card statement was $1853.04, and you had to pay a finance charge. The APR is 14.4%. So what is the monthly interest rate, or the MPR? Okay, what is that? Well, it's 14.4%. Divide that by 12. So let's do that. 14.4 divided by 12. And we get about, look at that, 1.2%. So there's your monthly rate. Okay, 1.2%. As a decimal, it's 0.012. We'll use that in the next calculation. Let me erase that. Okay, so the monthly interest rate as a percentage is 1.2%. Now the finance charge, FC is finance charge, is equal to your average daily balance multiplied by your monthly periodic rate. So the average daily balance multiplied by the monthly periodic rate. So it says up here that the average daily balance is 1853. So 1853.04. That's what the average daily balance was, multiplied by your MPR, which, as I said, is 1.2% or 0.012. So you convert to a decimal. So you take this guy and you convert it to a decimal. Divide it by 100. Shift the decimal place 2 places left. Do something like that. Okay? And you get a finance charge. So let's calculate that. So you type in $1853.04, multiply it by your monthly interest rate, which is 0.012. All right, double check your digits right there, and you should get about $22.24. $22.24. All right, make sure you round to the nearest penny right there. And that was in section 3.5, okay, or 3.5. We're talking about the average daily balance. Number 15, another average daily balance again. Okay, so let's do this. So on this one here, Natalie had these daily balances on her credit card for her last billing period. She did not pay a card in full for the previous month, so she'll have to pay a finance charge. The APR is 19.8%. Okay, so given that, so the APR is 19.8%. The monthly periodic rate is 19.8%. Divide that by 12. So what is that? Just doing some calculations in the beginning just to see what it is. Okay, so there's your monthly periodic rate is 1.65. So 1.65, make sure you put the percent sign. That's not a decimal yet. Okay. Now, how do you calculate the average daily balance? Because that's what we want to do first. So the average daily balance, ADB, okay, ADB is average daily balance, is found by taking the sum of all the daily balances, sum of all daily balances, all right, divided by the number of days, however that is. And I can't say it's 28, I can't say it's 30, I can't say it's 31, because I don't know depending on the month. So you have to add. So if you come up here at the table and add up the total number of days, we've got 9, 6 and 3 is 9, plus 10 is 19, plus 11 more is 30. Okay, so there's 30 days here total. Cool. All right, so what are the subtotals like up here? So for 6 days, we had a daily balance of 341.25. But what is the total for that? Okay, we'll call them subtotals. What is, I mean, for the first day it was 341.25. Second day, 341.25. Third day, 341.25. For 6 days it was that. But what is the total for that? So we have to calculate, 6 times that number, 341.25. What is that? So let's figure that out. You know what? Hang on for a second here. I'm just going to do something real quick. Going to shift this off to the side a little bit. Okay, I need some room. So let's do some calculations. So 6 times 341. So 6 times 341. All right, 25. That will give us the total for that many days. All right, for the first 6 days, which is $2,047.50. Then the next one here, we got 3 days at this other balance, so 843.25. So 3 times 843.25. Got to make sure you double check your numbers here. All right, and I get a balance of $2,529.75. So let's record that. So $2,529.75. And you keep on doing this for the next 10 days. Each of those 10 days had a daily balance of $1,502.35. So you got to multiply 10 times the $1,502.35. What does that give you? Well, you just shift the decimal over. But if you don't believe me, type in 10 times. Okay, if you really think you need to do this here, just type in the number. Only one decimal point. Okay, and notice you get 15,000. So $15,023 and looks like 50 cents. Okay, last 11 days. There are 11 days at this balance, so we got to multiply these guys. So 11 times, oops, got to go down to the next line in Desmos here. So 11 times the 2004, 25. So this is the last subtotal. So we have $22,046.75. Now we have to add all these. What is the total? The grand chamal. Okay, what is that total? So you have to add up these numbers here together and get a total. You have to add them. Okay, here we go. So I did it slightly different in class. I just typed everything into Desmos. I did it this way here. I went 6 times 341.25, 341.25 plus 3 times 843, 3 times 843.25. And then plus, and then the next one 10 times, so 10 times 1502 and 35 cents plus, and then the last one 11 times 2004 $25, and then I just hit return, and then boom, you get a big number here. So you get $41,647.50. So here we go. Let's put that in red. So $41,647.50. That is the grand total. So we take that down here. Take $41,647.50 and divide it by the number of days. So bring it down here. Divide it by 30 days. And so the average daily balance is something. So on the next line of Desmo, take $41,647.50 divided by 30, and you'll get your average daily balance, which is $1,388.25. Okay, that is your average daily balance, and you need to know that because the finance charge is always the average daily balance multiplied by your MPR, your monthly periodic rate. So you want to take this number here that you found and you want to multiply it by your monthly periodic rate. So you're going to take $1,388.25, multiply it by your annual or monthly periodic rate, which is 0.0165 as a decimal. Okay, and then what do you get? Well, I don't know. Let's calculate it. So you take $1,388.25 times your monthly periodic rate, and you get about $22.91. You got to round up right there. So $22 and looks like 91 cents. That is your finance charge. Okay, there we go. Big problem, huh? There's a lot of calculation in one. Be expecting that you need to be able to do this on your free response, okay, portion of the test, as well as multiple choice, but I'll break it down into smaller pieces. All right, but you need to be able to show your thinking, all right, and show the process. So keep that in mind. Let me make a little note of that. So for the free response, show process, okay, on this right here. Otherwise, I can't give you credit for it. All right, you got to show your thinking, guys. All right, section 3.6. Moving on. So open up your workbook here, section 3.6. Again, I keep telling you guys to use your workbook to your advantage because we've done all these problems. You know, the question is, do you remember all the processes, and do you know them really well? Can you do what we did, prior? So in this problem here, we got this credit card statement, and we don't know what the new balance is. We want to determine the new balance amount. So in general, again, open up your workbook on 3.6 because we've done this stuff before. To calculate the new balance, you got to take your previous balance, all right, minus any payments, because minus any payments or credits, because that's going to bring your balance down. It's going to decrease the overall balance. So minus any payments. You can think of that as a credit because it's going to credit your account, which brings down your balance because you're going to pay that off. That's a good thing. So when you send money from your checking account to your credit card account and you pay it down, that's a payment or a credit to your account. Now you may have some transactions or debits. Okay, so you have to add them. That's going to increase your balance. So in general, you're going to have to add in your debits. You're going to have to add in a late charge. We'll call that LC. FC for finance charge, LC for late charge. So you have to add in their late charges because they're going to increase your balance if they have any. And then, of course, you have to add in your finance charges because, well, that's going to increase your balance too. So that's how you do it in general. Okay, so let's put the numbers in here. You have from the previous balance $1,237.56. You pay down the balance $1,200. You send money from your checking account to your credit card, for example, and you pay down the balance. That's why we're subtracting. Now you go out and spend a large amount of money that month, so that's going to increase your balance. So you got to add that in. So $2,560.67. There's a zero late charge fee, so I'm going to put zero in there just to keep track of things. And then I've got a finance charge of $956. And this is what you put into Desmos. This is your new balance. So let's do it. So let's go down here and start off with $1,237, all right, and 56 cents. Okay, subtract your payment. You paid it down $1,200, but then you went and spent a lot of money, $2,560.67. And thank God you didn't have a late charge. You must have paid it on time. And then you have a finance charge of $963. So add, $956. So $9.56. So you have an overall new balance of $2,607.79. $2,607.79. That's your new balance. That goes in here. $2,607.79. Don't worry about the minimum payment. That's given to you on your card. Okay, that's given to you. You don't have to determine that. The credit card companies will tell you what the minimum payment would be. All right, number 17. Okay, different type of question. So in this case right here, we got a credit line of $9,000. That's your max you can spend. Okay, everybody has a credit limit on your credit card, and I said credit limit, but it's called a credit line. And that's the maximum amount you can spend on your card. The question is what's her available credit? Question mark. Okay, now the available credit depends on your new balance. So you have to find the new balance first. So step one, find the new balance. So here we go. So we're going to do the same thing as we just did in the previous problem. Okay, so new balance, NB for new balance, is equal to the previous balance, which is $6,556. She paid down the the account $5,200, so that's good. She had a big credit right there, so that was nice. She must have had a big paycheck. But then she has some transactions, some debits of $978.45. So she spent quite a bit of money there. So she paid it down by $5,200, but then she increased it $978. Hit by a late charge, so you have to add in the 20. There's your late charge. And then of course there's a finance charge, so you have to add in the finance charge of $1288. So that's your step one. So let's calculate the new balance here. Let's enter this entire thing in. So enter in 6,556. All right. Deduct your credit here. You paid it down 5,200, so that's why we're subtracting. But you went and spent some money, so we're going to increase the balance here by $978.45. We were hit by a late charge, $20, and we hit by a finance charge of $1288. All right, and we get a new balance of $2,311.89. So $2,311.89. Then after you know that, then you go to step 2. All right, the available credit is always found by taking your credit line, all right, minus your new balance. Okay, so let's do that. So your credit line is $9,000. Your new balance is right up here, so it's $2,311.89. Question is, what is that? So enter in 9,000, subtract your new balance of $2,311.89. All right, and you get an available credit of $6,688.11. Okay. Again, all these questions come out of section 6 in your workbook. So use your workbook to your advantage. Okay. Next one here, number 18. Marianne has a credit card with a credit line of $16,000. So we know the line of credit is $16,000. That's the max that she can spend. She made the following purchases right here. So we have to figure out what that is. The total, don't know what that is. We got to total this up. And then what's the available credit? So what we need to do is to the available credit in this case is going to be her credit line, all right, minus the sum of all the transactions. So I have to add up these 4 transactions. So let's go ahead and let's do that here. So it's going to be 16,000 in this case, all right, minus something. So what is that sum? So let's get the sum first. So enter in $1,274.90. Let's add these 4 transactions together. 256, all right, 21, plus 3346, plus, and then 953.01. So 953.01. Okay, now that's the sum of all the transactions. So I need to subtract that from the available, the credit line. So right there, that's $2,517.58. So for the difference of these two will give us the available credit. So all of these 4 transactions here was added up to $2,517.58. When you subtract the two, you take 16,000, subtract the $2,517.58, and you'll get your available credit at $13,482.42. So $13,482.42. This is the available credit. Okay, and that is how the game is played right there. All right, that's all from section 6. And again, use your workbook here, guys. Use your workbook. All right, I'm going to end it here. I'm going to do a 3-part video. In my last part, I'll handle the next section here, and I'll do this one here in a minute in part 3. All right, I'll see you soon in my next and last portion of the Chapter 3 review here in a little bit. Make yourself proud. Again, these are videos. Just go back and listen to it again, work it out in detail, and check your work. Okay? I'll see you in my last and final problem here in a few minutes. Hey, good morning, everybody. This is Mr. Ainsworth, and we are in financial algebra here in the Chapter 3 review, and we've gone through a lot already. So just going to give you a little taste of what we've been through here. This covers all 7 sections, going all the way back to section 1. Okay, so in the left-hand corner in the beginning of each problem set, I tell you the section number. So what you should do is get your notebook out, your workbook, your student workbook here, and use it to your advantage. Okay, we talked about down payments, monthly payments, finance charges. In section 2, we talked about how to calculate the monthly payment, the total payments, and the finance charge, given a table. And then we talked about the monthly payment formula and how to use that for the first time. In section 3, we talked about unsubsidized loans. Then we talked about subsidized loans in number 9. Then we talked about private loans and how they're different. And then we talked about in section 3.4 how to calculate a term, okay, the number of years of a loan given, let's say, a maximum monthly payment and a percentage rate. Oh, and a principal too, of course. And then, let me see, we talked about linear regression. I used decimals for this, and I talked about linear, quadratic, cubic regression. In section 3.5, I talked about some basics here, just how to go from APR to monthly, from monthly to APR, how to use your average daily balance and your monthly periodic rate to calculate a finance charge. Then we finally did an actual average daily balance problem right here. And then we talked about how to calculate a new balance, available credit, given a credit line and a new balance. And in section 7, we've kind of put it all together in this problem right here, where we're given a credit card statement and a bunch of information and some unknown. These blank spots are unknown. And we want to learn how to use what's called a credit calendar. What you're looking at here is called a credit calendar, a blank credit calendar, and to keep track of your daily balances so you can figure out your average daily balance, so you can figure out your finance charge, so you can calculate your new balance, and so therefore you can calculate your credit line, or your available credit, excuse me. All right, so a credit calendar, it keeps track of your daily balance. That's why we use it. So it keeps track of your daily balances, and that's why we use it. All right, so let's read the statement here, and let's check out what's going on. Okay, so the first thing we do as well, let's read the questions actually. So what amount should be in the box for the payments and credits? So we got to figure that out because we don't know what it is. We don't know what the total transactions are. We got to calculate the finance charge, which has to do with what's called an average daily balance. And then we got to, after we do all that, then we got to figure out a new balance, okay? And we also have to figure out the monthly periodic rate given the APR. So there's a lot of things unknown here that we need to figure out. So the first thing we ought to do, well, we can figure out the payments and credits. Okay, that's pretty straightforward here. So let's do that here. The payments and the credits. Okay, so there's only one payment or a credit, and it's right here in the middle. Okay, you paid down the balance of one by sending probably your money from your checking account to your credit card statement, and you paid off $190.60. So that right there, there's your payment and or your credit right there in the very beginning. So right there, let's put down $190 and it looks like 60 cents. Okay, just reading the statement right there. Okay, and what should be in the box labeled the transactions? Well, the transactions are debits. Okay, and so what we need to do is figure out that total. Okay, so the transactions, debits, if you will, charges, okay, are through here. So you went to the pastry shop and spent $27.68 and so on. So these are all debits in blue. So let me change colors here. just so you can see what I'm talking about. So the payments and the debits, the things that you spend money on, are in blue right here. You went to the pastry shop, you went to Corner Clothes, you went to La Petite Menu, and then you also went to the pharmacy, you went to the jeweler shop, and you went to an antique shop. And all of those are transactions. Okay, they're debits. So this area, you need to add here, and you need to add here. These are the transactions. And so obviously we just use Desmos. We just enter those numbers in. So I'm going to enlarge this so I can see a little bit better. And here we go. And again, use Desmos. Just keep track of your stuff. You can print it off at the end and submit your work. Real simple. So let's take 2768 and let's add it to 127.35. Let's add that to 8740. I mean, you just type it in, and as long as you can type the correct numbers in, you're good to go. All right, so you just keep adding these debits together here. 325.90, all right, and plus 870 and 21, and you get a total transaction amount of $1,495.84. Okay, that is your total transactions. So let's write that down. $1,495 and 84 cents. Okay, and that goes down here, and so $1,495.84. It's all blacked out, so I can't put it in there. Just that's the second answer. Okay, and then the third one here. What's the average daily balance? Well, to calculate that, we need to know what the daily balances are. That is a big question. So right now, we need to jump to the credit calendar and keep track of all this. Okay, now before we do this, the first thing I do know, and it's important to read the statement here, is, let's see here, is you want to know when your billing date was. So the billing date is April 6th, and all these transactions occur prior to the billing date. Okay, so we got to keep track of all these transactions and see how the daily balance fluctuates. It goes up and down depending on whether you're crediting or debiting from your balance. Okay, so I'm going to start here. It doesn't really matter where you start in the credit calendar because it's a blank one, because we really don't know, because I don't know the year, whether this is a Saturday, Sunday, Monday, or Tuesday or Wednesday. I mean, I really don't know. So you can start anywhere you want. I'm just going to put the 6th here. And what I'm going to do is I'm going to count backwards the number of days in the cycle. So another important thing that you have to look at is right here in pink, all right, the number of days in the cycle. And there's 30 days in the cycle. So what we need to do is count back 30 days. So I'm just going to enlarge this so you guys can see it a little bit better. So we have to count back 30 days. So count back 30 days. Okay, not too hard to do. So 5th, 4th, 3rd, 2nd, 1st. Okay, this right here is April, right? And then prior to April is March. So right here, this is March. And that's why in the statement here, there's transactions that occurred in March, because that is the month prior to April 6th. Okay, so we got to count back a total of 30 days. So here we go. Now March has 31 days total, so you got to keep that in mind. So 31 days in March. 31 days total in that month. And each month is different. Some days, or some months like February has 28 days. Some months have 30. Well, March has 31, so this is actually the 31st. So you got to keep track of it properly. So, and if you don't do that, if you start off with 30 instead of 31, then you're not going to get the right answers. Okay, so this right here is an important number because I'm starting counting backwards from 31. So, and I got to count back 30 days total. So notice that each row is 7 days, because there are 7 days per week, right? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and it's Sunday. Okay, or excuse me, Saturday. All right, count back. 28, 27, 26, 25, 24. That's 2 weeks. 23, 22, 21, 20. Oops, messed up. 19, 18, 17. That's 3 weeks. Okay, 16, 15, 14. You don't need me to do this. This is too easy here. That's 4 weeks. So I want to go 4 weeks and 2 days, right? This is 4 weeks right here. 4 weeks. All right, and that is obviously equal to 28 days. All right, so I got to go back 2 more, right? So this is 9 and 8. So this is my end right here. This is so I'm not going to use these here. So there's my 30 days going back in the cycle. So now you go back up here and you look at what your previous balance was. And that's the first day of the cycle, because this previous balance, which is right here, is what you use to start the new cycle, because this carries over from the prior month. So the previous balance, $560.30. So this is where you start. So $560.30. Okay, so the question is, how does the daily balance change, throughout the month? Because it doesn't stay the same. I mean, well, some days it stays the same, but if you make a transaction, whether you debit or credit, then the balance is going to either go up or down. If you spend money, the balance goes up. If you pay off, like a credit payment, which is called a credit, there's only one credit here. So this is a good thing, because you're paying off the balance. You're bringing the balance down. So you either pay it off, bring the balance down, or you spend money and the balance goes up. Just use your common sense. Okay, so now what happens? Well, this is on the 8th. What happens on the 9th? Well, on the 9th, if you read up here on the credit statement, it says you went to the pastry shop and spent $27.68, and so your balance is going to increase. And so this is where you start. So enter in $560.30, okay, and you're going to add that transaction of $27.68. So you're going to add $27.68. And now this is the new balance on the 9th, because you spent money on the 9th. It says so right here in the statement. So the balance increases, and this is every time you change a balance, change the color. Okay, you'll see why here after I'm done. It's going to help you keep track of all the daily balances. Okay, the question is like, how long does this occur? So on the 10th, does anything happen? Well, if you look up here, nothing happens till the 11th. So on the 10th, you have the same balance. So let's just color code these guys. I'm going to use blue here. So this month here, this day, excuse me, not month, but this day is the same as this day. So you have 587.98. Now on the 11th, okay, you go to the corner clothes and buy some clothes, and you spend $127.35. So the balance goes up. So you switch colors. Okay, so you enter in the previous balance of $587.98, and you add your transaction, which is $127.35. Okay, that's the balance on the 11th. So $715.33. Okay, now you don't spend anything until the 16th. So this balance stays the same until the next transaction date of 16th. So it stays the same all the way through here. So let's just jot it in here. 715.33, 715.33, 715.33, 715.33. It doesn't change because you didn't buy anything on the 12th, 13th, 14th, and 15th. You bought something on the 16th, and that's where the balance is going to go up. Okay, so how much? I don't know. Well, I do know. I spent $87.40, so it's going to increase. So 715, we're at 715.33. On the 16th, we spend $87.40, so we add $87.40. Now on that day of the 16th, it increases. As soon as you spend money, it increases that day. It changes. So your average daily balance changes as you spend money. Okay, and this is going to remain the same all the way up until the 21st, because on the 27th, it's going to go down because you're going to make a credit. Okay, you're going to pay down your balance. Okay, so let's switch colors here. So this balance of 802.73 is going to remain the same until the 22nd. Okay, so let's repeat that. So 802.73, 802.73, 802.73, 802.73, 802.73. It only changes when you make a transaction. So if you credit your account and you pay down your balance, it's going to go down. If you spend money, it's going to go up. All right, just use your common sense a little bit. So now at this point, we're paying it down. So we enter in 802.73. we subtract this credit of $190.60. Don't ask me why there's 60 cents there, but that's the way it is. Now you're down, the balance went down because you paid off your credit card. You paid off $190.60. So now you're at 612.13. So we switch colors. So let's switch to blue. Okay. Oh, purple. Purple's good. Okay, so we're at 612.13. 612. Oh, and then how far does it continue? Well, it continues all the way up to the 26th. Okay. So it's going to continue all the way to the 26th. Right to here. All the way to there. Okay, because on the 26th, you spend money again. Okay, so let me get my colors again. Okay, there we go. So 612.13, 612.13, 612.13, 612.13. Okay, now. I made a mistake. No, not that. There's one too far. That doesn't happen. So on the 16th it changes. So it only continues up to the 25th. That's what I meant. Okay, so because on the 26th we go to the pharmacy and buy some stuff. Okay, so on the 26th it changes. So let's enter in 612.13. And you go to the pharmacy on the 26th and you spend $57.30. So add $57.30. And notice that we went up, the balance increased to $669.43. And again, balance changes, change colors. Okay. So here we go. So 669.43. 669.43. And then it's going to stay the same until the 28th. So the 26th and 27th remain the same. Because on the 28th, you go to the jeweler's and you buy some jewelry. Oh my goodness. Maybe you have a girlfriend. I don't know. So let's change colors. So these two dates are going to be the same because, again, the balance only changes when you make a transaction. And that happens on the 28th. So something new happens right there. So on the 28th, you spend more money. All right, so you're at 669.43. On the 28th, you go to the jeweler's and you spend a lot of money. You spend $325.90. All right. So now you're at $995.33. So switch colors again. So let's just do red here. All right, so you're up to $995.33, and that's going to stay the same all the way to April 4th, up to April 4th. So really all the way through April 3rd. Okay, so I'm going to change colors once again. Okay, so this balance here is going to go all the way to April 3rd, or through April 3rd, because on the 4th it says that we go to Antique Shop. So what I'm going to do is I'm going to just repeat this number all the way through because it doesn't change until you make another transaction. That's the key idea. It doesn't change until you make another transaction. So it stays the same here. And this number here affects the average daily balance, which affects your finance charge. Now on the 4th, something happens. You go to the antique shop and you spend a lot of money. Okay, so now this changes. So we got, let's go to just black here. So we have to enter in $9.95. And let me see, 33 cents. And we go to the antique shop and we spend $870.21. Holy cow. Okay, so now we're at $1865.54. So now $1865.54. And that's going to stay the same because that's our last transaction. So this occurs all the way through here. So $1865.54, $1865.54. Now I know what the balance was on every day during the 30-day cycle. So now I can calculate the average daily balance by figuring out the totals. All right, now you can do it the most basic way to find the total of all these numbers. There's 30 of them there. Is simply add them all up. Okay, so you could get that. But there's a quicker, little bit easier way. So what we do is we calculate subtotals. All right, so to find the total sum, let's see here, let's write down total sum. I'm going to be calculating subtotals. So the first number in the calendar that I see is $560.30. So here we go. So $560.30. And there's only one day at that amount. But I see 2 days at $587.98. So I take 2 times $587.98 because there's 2 days. I'm going to color code this just to make a point. All right, so look in blue here. So on the 9th and the 10th, they're the same days, right? There's only 2 days at that amount. There's where the number 2 comes from. So instead of adding them up individually, you use multiplication because there's 2 of them. Now in green, all right, the next part of the calendar here, okay, I'm talking about the 11th through the 15th. Okay, we have how many days? Well, 1, 2, 3, 4, 5. We have 5 days, and each of those days is $715.33. Then we have 1, 2, 3, 4, 5, 6. From the 16th to the 21st, there's 6 days at 802.73. So 6 days at 802.73. Those are the ones I colored in yellow. Okay, from the 15th through the 16th through the 21st. And then in purple, okay, we have 1, 2, 3, 4, 4 days. 4 days at $612.33. We're rocking and rolling here. Okay, so there you go. So far looking, I think, good. Okay, and then we have these 2 days in green right here. So from the 26th and the 27th, we have 2 days at $669.43. All right, that's in green. Just color coding my work here just for fun. Okay, and then in red or in blue, actually blue highlighter, from the 28th to the 3rd, I have 1, 2, 3, 4, 5, 6, 7 days. So 7 days at $995.33. Okay, and then I have 3 days remaining, so I have 3 days at $1,865.44. If we add these up, okay, add, we get the grand total, which we need. We get the total sum of all days, okay? And this is what we put in the Desmos right here. Okay, so let's do it. We start off with $560.30, so $560.30 plus 2 times 587, so 2 times 587.98, right? Plus 5 times the 715.33 plus 6 times 802.73 plus 4 times the 612.33 plus 2 times the 669.43. Double check your numbers up there. Plus 7 times 995. It's going to be a big number here. 33 plus 3 times the 1865.44. And hopefully I didn't make a mistake, which I think I did. So let me check. Yeah, I entered something incorrect here. So let me check. I made a little mistake. So when you do this, because obviously I've done all this before, you want to check your entries. And it is so easy to make a little mistake. So 560.30, that's correct. 2 times 587.98. 5 times 715.33. 6 times 802.73. We're right here. Just use your right arrow key. 4 times 612.33. Oh, there's my mistake right there. Okay, it's supposed to be 13. That's my mistake. So I'm going to change that to 13. This will happen to you. So right here, it should be 612.13. I wrote down 612.33. That was a mistake. So it changes to 1 right here. Okay, and then let me just keep checking here. Let's see, 2 times 669, 43. And then 7 times 995, 33. And then 3 times 1865. Oh, shit, look at that. I put 44. It's supposed to be 54. I made 2 mistakes. So look at this. In my credit calendar, it says 54. I put 44. So right here, this should be a 5. So change this right here to a 5. There we go. And that is the correct value. Okay, that's why you always check your work, my friends. Okay, and that's why I publish the answers for you guys so you can check your work. This comes from your workbook in section 3.7, guys. This was your homework problem. Okay, so there we go. That's our total sum. So let's write it out. So $26,480.60. Big number. Okay, now to calculate the average daily balance. Average daily balance. Okay, the way you do that is you calculate the total sum of all the days divided by how many days there are in this month, which is 30. So for us, it's 26,480.60 divided by 30. So you enter that number in, so 26,480.60. Make sure that you put it in correctly here, divided by 30, because there's 30 days in the business cycle, or in this credit cycle. And you get 882.69, because you got to round up. Okay, so the average daily balance in this case is $882, and again, 0.686, round up to 0.69. And again, round to the nearest penny. So that is the third question here. So this, if we call this A, this B, okay, C, D, E, and F. Okay, that's part C. So the average daily balance is 882.69. So 882.69. Boom. Got it there. Okay. And then next, what is the finance charge? Well, the finance charge, my friends, deals with the average daily balance. Okay, so the finance charge, here we go. Finance charge is found by taking the average daily balance and multiplied by your monthly periodic rate. Now, let's look at the credit statement. The APR is 15.6%. So the monthly periodic rate is equal to the APR divided by 12. So if I go over here and I enter in 15.6%, right, divided by 12 to go to monthly rate, I get 1.3%. So the monthly periodic rate is 1.3%, or as a decimal, 0.013. So let's come down here and let's use it. So what I do know is I do know that my average daily balance is 882.69. So 882.69. I multiply that by my MPR, which I said is 1.3%, or 0.013. Okay, and then I get a number here. This is my finance charge. So you take 882.69 and you multiply it by your monthly periodic rate in the form of a decimal. All right, and you get $11.47. So $11.47. There's the finance charge. All right, so we have some big results here. Yeah, first result is the average daily balance. Second major result is the finance charge. Okay, so 1147. So that goes up here. So 1147. And then what is the new balance? Well, in the table here, the new balance is unknown, but we know the payments and credits. Okay, that's we know the payments and credits is right here. So that right there is $190.60. Transactions, we wrote that down somewhere. Let me see. So that's this number right here, that's $1495.84. We don't have a late charge, it says 0, but the finance charge, we do have a finance charge. We just calculated that, and then that's $11.47. The question is, what is this? What's the new balance? Well, the new balance is the previous balance minus the payments, because it brings it down, so you subtract it, plus the transactions, plus the late fees, plus the finance charge. That's how you calculate the new balance. All right, so here we go, new balance. Okay, you take the previous balance, subtract any payments you make. They're called credits. Okay, you have to add in the transactions that you make. Those are called debits. You have to add in any late fees. Okay, let's just use LF for late fees right here. So late charge, late fees, and then FC for finance charge. So late fees plus finance charge. Okay, LF is late fees. So here we go. Let's get the previous balance. I forgot what that is. So looking at the credit balance right here, or the credit statement, the previous balance is $560.30. So $500, 500. Come on, Ainsworth. 560.30. It's kind of hard to read these things when they're just so small. So and 30 cents, and then you paid off $190.60. If you look at the top there, you spent $1,400.95 $95.84. There are no late fees. It says so up there, but there is a finance charge of $11.47. Okay, so you just work this out and you just type it all in and let the calculator or Desmos do it for you, because that's how we roll right now. Okay, and so we subtract the payments because this will bring down our balance, and then you go spend a whole lot of money, spend $1,495.84. Oops. Okay. I got a typo there. So $1495.84. Be careful. All right, plus 0 plus 1147. Okay, and that will give you a new balance of $1,877.01. So here we go. So the new balance is another big result, $1,877.01. Okay, so let's highlight that. That's your that's our new balance. That's a major result. Okay, so new balance time. So now we know that. Now we can calculate the other things. So the new balance is $1,877.01. And now what is the available credit? Okay. Now, these are all good questions. That's why I love this problem here, because it kind of puts together the last 3 sections all together, or 4 sections. All right, so the credit, available credit, is your credit line minus the new balance. Okay, so let's do that. So conceptually speaking, so the available credit, I'm going to start off with that. The available credit is equal to your credit line, whatever the max is, your credit line, which is basically a max, the max you can spend, minus the new balance. Whatever it is, whatever it says on your statement. So you got to figure out the credit line. So we got to go up to our statement and read it. Okay, now if you look here, the credit line is at the bottom. It's a $5,000 credit line. And we already know the new balance. I just said it was $1,877.01. Okay, so I got to subtract that. I got to take 5,000 minus the $1,877.01. Okay. Getting a little crazy with my zoom here. So my $5,000 max spending limit credit line minus my new balance, which is here, $1,877.01. This will tell me my available credit. So enter in on the next line 5,000 minus the new balance. That's how much I've spent so far with all my transactions. Okay, and I have a credit, available credit of a little over 3,000. So $3,122.99. That is my available credit, and that's another big number. Okay, so all of these are going to be individual questions on your exam, and it all relies upon what's called the credit calendar. Okay, so you have to go back and ask yourself, do you understand how to build this credit calendar? Because it keeps track of your daily balances. And that, my friends, is what gives you the ability to calculate your average total balance, or average daily balance, because you have to take the total sum divided by 30. And if you know the average daily balance, well, guess what? You can calculate the finance charge. If you know the finance charge, you can calculate the new balance. And if you know the new balance, then you can calculate the new or the available credit. So like one thing builds on another. Okay. So there you go, my friends. Okay. That is the last 4 sections reviewed, all in one problem. That was pretty bitchin'. Okay. All right. Okay. Once again, this is financial algebra. Okay. As you guys know, and you're with me. Okay, my name, Mr. Ainsworth, and hopefully you guys learned something right here, and hopefully I explained it well enough so that you guys fully understand it so that you can do this on your own given a credit card statement. You need to learn how to build a credit calendar so you can keep track of your daily balances, and so you can answer all these basic questions right through here. So do your best, and I'll see you in my next lesson. Bye-bye.